So let's begin by taking a look at number 1 in your examples. So it says use substitution to solve each system of equations. And we've got those two equations listed there. So much like Indiana Jones in his attempt to use substitution, we're going to try to do the same. So in the movie clip you watched, Indiana Jones tried to substitute a bag of sand for a golden statue. What he was trying to do is replace that golden statue with something of equal weight. So for us, we want to make sure that when we make substitutions, we're substituting things in that are of equal value. So when you look at this bottom equation in our first one, it tells us that y is equal to 6x minus 7. So what that means is every time we see a y, we can substitute 6x minus 7 in for it. So you'll notice in the first equation, we've got this y right here. So what we're going to do is we're going to take that y out and we're going to substitute in 6x minus 7 for it. So it's going to look like this. That first equation is going to become 3, and now I'm going to substitute my 6x minus 7 in for y. And then the rest of that first equation stays the same. So I still have plus 2x, and then on the other side I have 19. So what you'll notice now is that the equation, that first equation, became a little messier than it was to begin with. But notice now I only have one variable in my equation. I have x. So what we're going to do next is we're going to use the techniques that we've already developed to solve this equation for x. So to start, I'm going to take my 3 and distribute it. So we get 18x minus 21 plus 2x equals 19. Okay, next I want to combine my like terms. So you'll notice I've got 18x and 2x, so that's 20x. And then minus 21 equals 19. Let's add 21 to both sides. And that gives us 20x equals 40. And next we'll divide both sides by 20 to get x alone. And we get x equals 2. So now the question is, am I done? Well, no, if you remember from the class that we talked about the graphical method for solving these systems of equations, a solution consists of both an x-coordinate and a y-coordinate. So we figured out now that our x-coordinate is 2. So to find our y-coordinate, we're going to use substitution again. So what we're going to do is take x equals 2, and we're going to plug 2 in for x in either one of the two original equations that we had. So to me, it looks like it's going to be easiest to figure out y if we substitute 2 in to this bottom equation. So that's exactly what I'm going to do. So if I substitute in, I'm going to have y equals 6 times 2 minus 7. And now if I just use my order of operations, 6 times 2 is 12. 12 minus 7 is 5. So now I've got my full solution. So when I write it out, my full solution, the x-coordinate is 2, the y-coordinate is 5. The final step in the process should be to check my solution. So if I take 2 and plug it in for x, and I take 5 and plug it in for y, those coordinates better be solutions to both equations. So let's just check real quick in the first equation. So I have 3 times y. Well, we said y is 5. So 3 times 5 is 15, plus 2 times x. Well, x is 2. 2 times 2 is 4. So we have 15 plus 4 does equal 19. And if I check on the bottom equation, well, I'm plugging 5 in for y. So on the other side, I have 6 times 2 is 12, minus 7 is 5. So I get 5 equals 5. So that means that 2, 5 checks out as a solution. Before looking at our general steps for solving systems of equations by using the substitution method, let's look at a second example. So number 2. So in this example, what you'll notice is that it's a little different than the first one. In the first equation, if I drag it over, the bottom equation, notice that y was all by itself. The top equation wasn't so, but in the bottom equation, y was all by itself, so it was ready for us to do a substitution. You'll notice in number 2, that's not the case with either variable. In the top equation, both b and a are on the same side, so neither one is by itself. And in the bottom equation, same thing. You'll notice that both a and b have numbers with them. Neither one is isolated. So our first step, if we're going to use the substitution method, is we want to isolate one of our variables. It doesn't matter which one we isolate, so what I would suggest is using the one that's easiest to isolate. So when I look at these two equations, to me, the bottom equation jumps out at me as being easiest to manipulate and work with. And specifically there, I'm thinking that if I want to get b alone, that process shouldn't be too bad. So I'm thinking I'm going to take this bottom equation and I'm going to try to isolate b. How would I do that? Well, to isolate b, we have to get rid of that 3. So the way we're going to get rid of that 3 is subtract 3 from both sides. That gives us b equals 2a minus 3. Now we're all ready to substitute. So our equation is all set up to use that substitution method. Let me make this b a little bit better. So how do we do that again? Well, the bottom equation says that every time we see a b, we can plug 2a minus 3 in its place. So what I'm going to do is look at the first equation, the one that we haven't used yet, and I'm going to look for b's. Every time I see that b, I know that I can plug this 2a minus 3 in its place. So that's exactly what I'm going to do. So over here on the side, I've got 6 times, and now I'm going to plug my 2a minus 3 in for b, plus 11a, and then equals 28. Okay, now notice, again, just like in the last example, I only have one variable in my equation. I've got a. Now it's in 2 different spots, but there's only one type of variable. So now I'm just going to use our techniques to solve this. So start by distributing. So we get 12a minus 18 plus 11a equals 28. Next, I'm going to combine our like terms. So we've got 12a and 11a, that's 23a minus 18 equals 28. Add 18 to both sides, and that gives me 23a equals 46. And now I'm going to divide both sides by 23, and that gives me a equals 2. Okay, again, I'm not done yet, because when I look back at my original equation, my original equations had 2 variables. They had a and b. So that means a solution has to be both an a and a b value. So now that I know that a is 2, I'm going to go back to, again, I can go back to either one of these equations. I can go back to the first one, I can go back to the second one, or I can even substitute into the one that we created down here by solving for b. And that's exactly what I'm going to do, because that one's set up for me really nicely. So I'm going to use this bottom equation, and now in for a, I'm going to plug our 2 in. And now if I use order of operations, 2 times 2 is 4, minus 3 is 1. And so that means my solution, a is 2 and b is 1. And so remember, when I'm doing coordinates, I always put my coordinates in alphabetical order. So the first one is a, second one is b. Now let's check to see that those solutions do in fact check out. So if we look at the first equation, if I plug 1 in for b and 2 in for a, 6 times 1 is 6, 11 times 2 is 22. 6 plus 22 is 28. So that checks out. In the bottom equation, 1 plus 3 is 4. And then 2 times 2 is 4 on the other side. So that checks out as well. So this solution works. Great thing about solving systems of equations is that there's a really nice way to check your answer. So now let's look at what exactly we did generally. Let's look at our steps. So the first step when we solve a system of equations using the substitution method is that we want to isolate one variable. So in the first example that we did, y was already by itself. We didn't really need to take this step. In the second example that we did, b wasn't by itself, so what we had to do was subtract 3 from both sides to isolate it. So that's the first step. Second step then is we substitute and we solve. Okay, so if we look back at our two examples, the first one I already got rid of, but the second one, after I figured out that b was equal to 2a minus 3, then we took the first equation and we substituted in this 2a minus 3 for b. So we took b out, we plugged 2a minus 3 in its place, and that gave us an equation with only one type of variable, only had a's in it. And then we solved that equation for a, which gave us a equals 2. The final step then in the process, in terms of solving, is to go back and find the value of the other variable. So what I'm going to call that is back substitute. And then the fourth step in the process is to check. So remember, with systems of equations, there's a really nice method for doing that, and so you want to make sure that you always check that your solution works. Okay, so now that you've got the process down, what I'd like you to do is to try numbers 3 and 4 on your own. Pause the video, and then after you've tried 3, you can restart it. Then try 4, pause the video while you're attempting it,